This video shows how to test the normality assumption as a requirement for the independent samples t-test in SPSS. First question: what has to be approximately normally distributed? It is the test variable for each group that should be approximately normally distributed. There are three possible ways to go about this. First, an analytical test, like the Shapiro-Wilk-test or the Kolmogorov-Smirnov-test. Second, a histogram. Or third, a QQ plot. The Shapiro-Wilk-test and especially the Kolmogorov-Smirnov-tests are oversensitive to unimportant deviations from normal distribution in large samples, and they also lack power in small samples. This is a phenomenon for all analytical tests, for which you can find a source in the video description. A QQ plot is the easiest to interpret, therefore we continue creating one, or rather two, one for each group you are comparing. To do this, go to Analyze, Descriptive, and Explore. Put your test variable in the dependent list box, and add the group variable into the factor list box. Next, go to Plots and deselect Stem and Leaf. Also, check the box for Normality plots with tests. Click Continue and then OK. You'll get plenty of tables and graphs now. I already mentioned that it will be in your interest more often than not to ignore the tests for normality, especially with large samples and resulting type 1 errors. Focus on the normal QQ plots. You will get one for each group. The dots represent the observations and the line the perfect normal distribution. Therefore, the distances between the dots and the line should be minimized. There will be acceptable deviations, especially on the edges of the distribution, meaning the upper right hand corner and the lower left hand corner. For my test variable and groups, deviations are not of concern, and I can calculate the independent samples t-test now, which is shown in the following video. If you, however, cannot observe an approximate normal distribution, you should use the 2-sample Mann-Whitney-Wilcoxon test instead, or apply bootstrapping to your independent samples t-test.